Got me falling right back.
The wrap panel positions the elements in it in a sequential position from left to right. And then if necessary, you'll get additional lines. So let's say you had 10 images, and the window was wide enough to display 5 of them. 5 of them would be on the top line, and then there'd be a second line of another 5. If you made the window wider, you might get fewer lines. If you made the window narrower, you might get additional lines. By default, elements are laid out from left to right. If you want them laid out from top to bottom, you set the orientation property to vertical, and then you'll get as many columns as you need. Let's go see. And the wrap panel by default just lays its elements out from left to right, and if it runs out of room, then it creates a new row and continues laying out elements from left to right. So here I have a wrap panel with 6 buttons. Each of them has a margin of 10 all the way around. And when I fire this up, by default, 4 buttons fit on the first line, and then it creates a second line. If I narrow this, then it will continue resizing and will create as many rows as are required to fit all of the buttons. If I make it wide enough, they'll all fit on a single row. If I make it narrow enough, they'll each get their own row. Now you typically probably wouldn't do this with buttons, but you certainly would do it with images or movie thumbnails. By default, the wrap panel lays out its elements horizontally. If you set the orientation property to vertical, then it will lay its elements out vertically, top to bottom, and then left to right. So here by default, 6 buttons fit in the left row, and then the other 4 get their own column. If I make this taller, I can get them all in one column. If necessary, it'll put them all in separate columns. So this is not literally one row of buttons, this is 10 columns of 1 button each. And that is the wrap panel. You can use the dock panel element to position elements along one edge of the window. Left, top, right, bottom, of course. And it will then arrange the elements horizontally or vertically relative to each other and stretch the controls so that they're always against one of its outside edges. By default, elements are docked to the left, but you can control this by using the dockpanel.dock property. And you would set that on each element to control where it docks. And the default value of this is left. If you wanted to dock a button to the right, you'd set its dockpanel.dock property to right. And the dockpanel.lastChildFill property of the dock panel controls whether the last element it draws fills up the remaining space. And by default, this is set to true. So let's go see how to use the dock panel and also how to use these 2 properties to control how elements get docked. Let's take a look at some dock panel examples. Here's our first example. I have a dock panel with a text block and 4 buttons. And the dock panel positions elements along one edge by default, and that edge is the left. So it essentially lays out these elements horizontally from left to right. To that extent, it's doing the same thing as the stack panel would if I set its orientation to horizontal. The big difference is that button 4 has been stretched to fill out the remainder of the space. By default, the last element you add to a dock panel fills up all the remaining space. So if I make this window even wider, button 4 will always resize to fill up the available space. Now if I don't want that, I can change that behavior by setting the last child fill property of the dock panel to false. And now you can see that button 4 does not resize to fill up the available space. I can make this window wider and narrower, button 4 stays the same. So at this point we might be asking, well, why would I use a dock panel instead of a stack panel? So far they seem to be doing the same thing. Well, if you set the dockpanel.dock property of elements, then you can control which edge they're docked to. So let's take a look at our next example. And here, what I've done is I've set the dock panel.dock property of the text block to top. Button 1 is docked to the top. Button 2 docked to the left. Button 3 docked to the right. Button 4 docked to the bottom. So now if I make this window wider, button 3 will always be docked to the right side edge. And if I make this window taller, the text block and button 1 stay docked to the top. Button 4 stays docked to the bottom, but by default it resizes to fill the available space. I can control that again by setting last child filled equal to false. And now button 4 stays docked to the bottom, but it doesn't fill up the available space. So if I make the window taller or shorter, the text block and button 1 stay where they are, docked to the top. Button 4 will stay docked to the bottom. If I make the window wider or narrower, button 3 will always stay docked to the right. Now button 4 is docked to the bottom, but notice that it doesn't get all of the bottom. That's because the order that you add elements to a dock panel matters. The text block is the first element. It's docked to the top, so it will get all of the space on the top. Button 1 is docked to the top, so it will remain essentially docked to the bottom of text block 1. Button 2 is next. It's docked to the left. It gets all of the left edge not already taken up by the text block and button 1. Button 3 is docked to the right, so it gets the entire right edge except for the space taken up by text block 1 and button 1. And then finally, button 4 is docked to the bottom, but it only gets the remaining space. If I want button 4 to take up the entire bottom, I can get that, but in order to do that, I have to change its order. So now inside this dock panel, text block 1 appears first, then button 1, then button 4. And so the runtime will give button 4 all of the bottom edge. Then buttons 2 and 3 are docked to what's left of the left and right margins. The stack panel, wrap panel, and dock panel are simple containers you'll use when you create user interfaces. You can use them by themselves. So in other words, you'll have a window or a page that has just a stack panel or just a dock panel. But typically, you'll combine them and use them together to control your layout. So for example, you'd have 2 stack panels inside a dock panel to create a common dialog box. What do I mean by this? Let's go see. On the left, you can see a dialog I wanted to create. I want to display a name and an email, and then I want buttons so that the users can scroll forwards and backwards among customers or contacts or whatever is in there. And then I also wanted an OK button. And I want the previous and next buttons to be on the left and the OK button to be on the right. And I basically want them to stay there. And then I want the text boxes to stay at the top of the window. So my outer element is a dock panel. And then inside I have 3 stack panels. The first stack panel contains the 2 text blocks and the 2 text boxes. And that's docked to the top. The second stack panel contains the previous and next buttons, and I've docked it to the left, and I've set its orientation to horizontal, so the buttons will be laid out from left to right. I set their minimum width to 50, so because they're a particular width, and they're docked to the left, those buttons are not going to resize. They're going to stay on the left-hand side of the window. The next stack panel contains the OK button. It's docked on the right, and that button's minimum width is set to 50 as well. So that button is going to stay on the right. Now, if I just had an OK button, I don't necessarily need a stack panel. I could have docked the button on the right, but I built in some additional flexibility because maybe I want to add a cancel button at some point. Then what I also did for the 3 buttons is I set their vertical alignment to top, so they're always going to stay essentially in the same position relative to the email text box. So let's run this. And let's get the first nesting example. So you can see that the previous and next buttons are docked on the left, OK is docked on the right. And if I resize this window, if I make it wider, the OK button stays to the right, these buttons stay to the left, and if I make the window taller, all of these controls stay where they are, because the name and email text boxes are docked to the top, and the previous, next, and OK buttons are in stack panels, and their vertical alignment is set to top, so they basically stay at the top of the stack panel, which isn't moving because the controls on top of it aren't moving. So all I get is white space at the bottom. Let's look at another example. And in this example, I have delete, save, and OK buttons, and I want those to always be at the bottom. So again, I'm using a dock panel, and I've set last child fill equal to false because I don't want the last element in there to resize itself. I have a list box which displays customers, and that's docked on the left. And because it's the first element listed in the dock panel, it's going to take up the entire left-hand side. My text boxes and text blocks are in a stack panel, and that's docked on the top. And it gets all of the top that's not taken up by the list box, so it's going to fill up the remaining window between the list box and the right-hand side and will always stay docked to the top. And then I have a stack panel which contains my buttons, and it's docked on the bottom. And now when I run this is the second nesting example. Notice we start out with the list box on the left, text boxes on the top, buttons on the right and the bottom. And as I make this window taller or shorter, those buttons will always stay docked on the bottom. And if I make the window wider, they again stay docked on the bottom right. The list box stays the same width. The text boxes will fill out to take up the rest of the screen. So by nesting containers, I have much more control over how things lay out. And with not a huge amount of XAML, I get windows that are the data entry forms I want. You can use the grid to more precisely position content in rows and columns. It gives you more control on where your content is than any of the panel controls you've seen. To define a row or a column, you use a row definition element or a column definition element in your XAML. You can type these in XAML. You can also click in the margins of the window and have Visual Studio add the row and column definitions. And then to place an element in a particular cell in the grid, you set its grid.row and grid.column properties. If you want an element to occupy more than one cell, either horizontally or vertically, then you can use the grid.rowspan property. There are three mechanisms you can use for sizing cells in a grid. You can use automatic sizing, and in that case rows and columns will be evenly spaced. And there are two ways you can specify this in your XAML. You can set the height property of the row definition to auto, or you can leave it off, because automatic sizing is the default. You can use absolute sizing where you specify a particular size. So in this example, we've specified that we want this particular row to be 50 pixels high. And you can use proportional sizing to divide space proportionally. So let's say you have 5 rows and you set the height on each of them to an asterisk, then each row would get 1/5 of the available space. If you had 4 rows, they'd each get 1/4 of the available space. You can fine-tune that by adding a number. Let's say you have 2 rows and you set the first height to star and the second to 2 star. This says that the first row gets 1/3 of the available space and the second row gets twice that, or 2/3 of the available space. So let's go see some examples of using the grid. Here's a simple grid with 3 rows and 2 columns. And notice that I'm not specifying any height for the row definitions or the column definitions, so they will automatically be sized. Each row will be 1/3 of the height of the window, each column will be half the width of the window. And then I fill each cell of the grid with a text block. So this first text block, the text is R0C0, and I put it there by setting grid.row equals 0 and grid.column equals 0. This text block is in the first row, second column, second row, first column, etc. Now the default for grid.row or grid.column is 0, so I don't literally need to specify that, but I find it more helpful if I specify both. And now when I run this, let's go into grid examples. Here's automatic sizing. The columns will always be half the width of the window, and the rows will always be a third of the height of the window regardless of the size. So the space is automatically proportioned evenly. In the second example, I'm using absolute sizing. So I've specified that the first row should be 50 high, the second row should be 150 high, and the third row should be 75 high. These are pixels. And I want the first column to be 50 pixels wide and the second column to be 225 pixels wide. So we go back and run this. Now notice that the first column is 50 pixels wide, but the second column, even though I said it should be 225, will actually be all of the remaining space. And I said that the first row should be 50 high, the second row should be 150 high, the third row should be 75 high. The third row actually gets all of the remaining space. So when you use absolute sizing, the runtime is going to essentially not so much ignore what you ask for the last row and last column, but it'll only be the default. Once you resize, both of those will get what's left. In the third example, I'm using proportional sizing. So the first and third rows have their height set to star, and the second row has its height set to 2 star. So this basically says that the first row should be a quarter of the height, the third row should be a quarter of the height, and the second row should be 2/4 or half of the height. The first column has its width set to star, the second column has its width set to 4 star, so the first column will be 1/5 the width of the window, and the second column will be the remaining 4/5 of the width. And again, that's proportional, so regardless of the size, the first column is 20% of it, and the second column is 80%. The first row is a quarter, the third row is a quarter, and the second row gets half of the height. Now you can combine these sizing mechanisms. So here I've said that the first and third row of the grid should be 50 pixels high, and the second row should be all of the remainder. And the first column should be 100 pixels wide, the second column should get the remainder. So regardless of the height of the window, the first and third row are 50 pixels high, and the second row gets what's left. And regardless of the width of the window, the first column is 100 pixels wide, and the second column gets what's left. In the fifth example, I'm doing a little report in a grid here, and I want to span columns. So let me call this up so we can see the actual grid lines. All of the columns and rows are evenly spaced. My first text block is annual sales by region. I put it in grid row column 0, but then I span 4 columns. So it actually spans the entire width of the grid. I've got it horizontally aligned in the center and vertically aligned in the center, so this text will be in the center of this row. This text block for east, I've got in row 2, column 0, but it's spanning 2 rows, so it spans vertically across rows 2 and 3. And then sales unavailable is in the bottom row, spanning these 2 columns. And because I'm using absolute sizing, regardless of the size of the window, the cells are all evenly sized, and the title stays in the center, and east and sales unavailable span their 2 rows. And in the final example, I'm using a grid to lay out a data entry form. I'm going to look at this first in design view because I want to see the grid lines. So I've got the name text block and the text box in the first row, email, text block and text box in the second row, etc. This contact info text block, which is right here, is actually in row 0, column 0, but it spans 2 rows, so I wanted it centered vertically in between name and email. Then name and email, etc. are text blocks that have their horizontal alignment set to right, so they would butt up against the right-hand side of the column. And then the text boxes are in the 3rd column. Now the buttons, clear and submit, are in a stack panel with orientation horizontal, and they're in this last column. Grid row 4, column 2. So now when I run this, because clear and submit are in the last row and last column, they will always stay in the lower right of the form. Now because I'm using grids with automatic sizing, the distance between the text boxes will increase or decrease as I change the size of the form. So whether in this example you use a grid or a dock panel kind of depends on how important it is to control the spacing between the 2 text boxes. The Canvas container differs from the previous containers because it places elements according to coordinates. So in that sense, it works like layout works in Windows forms. And because elements have fixed coordinates, they don't resize at runtime. To place an element where you want it, you set the canvas.left, canvas.right, canvas.top, canvas.bottom properties. And these are pixels relative to the left, right, top, or bottom of the container, which would typically be a window. So the benefit of the canvas is that you can put controls exactly where you want them. The drawbacks are that this can be quite time-consuming and laborious, it's harder to line up elements, and you don't get resolution and size independence, which is one of the big benefits of XAML. Here's an example of using the canvas to build a data entry form. In the previous demo, we used a grid to do this. Here we're using a canvas. The canvas contains text blocks and text boxes and buttons, and then each one of them has either the left and top or bottom and right properties set. So this first text box, contact.info, has its canvas.left property to 15 and its canvas.top property set to 50, saying that this should start 15 pixels in from the left and 50 pixels down from the top. And then for each of these controls, I've set either the left or right or top and bottom to specify its position. So this name, I said 35 down from the top and 225 in from the right because I want name and email to line up on their right. If I had used the left properties of these, I could get these to line up on the left but not on the right. Because I want them aligned on the right, I used the right property. For the text box, I said 25 in from the right, 35 down, so there's 25 pixels here, 35 there, and then for this text box, the same 25 from the right, 70 from the top. For the clear button, 90 in from the right, 25 up from the bottom, and the submit button, 25 in from the right, 25 up from the bottom. And now when I run this, my form stays laid out, and if I resize this, the controls are going to move because I specified that these line up on the right, these line up on the left, so the space between contact info and interests will increase, and it's also possible that I can get my text boxes and the name, email, text blocks to be to the left of their labels. It's a bit of a mess, actually. So a benefit of the canvas is that you can get controls exactly where you want them, but the downside is that it's hard to do, and it's not necessarily going to be respected when you resize the form. So it's probably best for graphical elements on a form that can't be resized. So the canvas has specific uses, but probably not for data entry forms. Coming from a Windows Forms background, the first time I saw an existing application built in XAML, I had no idea what was going on. In Windows Forms, you have a form and then you add controls to it. How hard is that? But in XAML, you can have stack panels and wrap panels and grids, and they can all be inside each other, and then there are the controls. I truly believe that the layout system is the hardest thing to figure out when you start learning XAML. And that's because until you understand how it works, you can't get your user interfaces to look the way you want them to. And if you can't do that, you can't build an application you'd let anybody else use. So hopefully, in this section, I've helped you demystify layout in XAML. Once you understand the basics of it, it's not that hard, and you can get back to being in control of the UI in your applications.
Promise that you'll catch me.